Next is intermediate languages. Intermediate languages are designed to use by the compilers. They are the language of an abstract machine designed to aid in the analysis of computer programs. In this, compiler first translates the source code into an intermediate code. So in intermediate languages, what happens? First, the source code gets converted into an intermediate code as an intermediate step before generating machine code for the target machine. So this source code getting converted into the intermediate code is the middle stepper, that is the intermediate step, the between step. Before the source code gets converted into the machine code, there is a step of converting it into an intermediate code. The design of intermediate language typically differs from that of a practical machine language in three ways. So what are the three ways in which the intermediate language differs from a practical machine language? Each instruction represents exactly one operation. Second is instruction set does not include control flow information. Third, the number of registers available may be large, even limitless. And fourth, syntax tree and postfix notation are two kinds of intermediate representation. The third kind of intermediate representation which is commonly used is the 3-address code. So the 3-address code is very important, and also syntax tree and postfix notation. Now, the unique features of a intermediate code are these three things, that is syntax tree, postfix notation, and your 3-address code are the unique features. So first we'll see the postfix notation. So what are the rules for postfix notation? Postfix notations are, first rule is operand appear before their operators. If E is an expression of the form E1 operation E2, the postfix notation of E is E1 E2 operation. So say for example, if I have E1 as 2, operation is a plus, E2 is 5. Then the postfix notation of this will be E1 2, E2 5, and after that we will write the operation, that is plus. This will be the postfix notation. Let's see the second rule. If E represents variable or constants, the postfix notation of E is E itself. Say for example, if your E is 2, then the postfix notation of E will also be 2. Why? Because 2 is a constant. So postfix notation of a constant is the constant itself. Postfix notation of a variable is a variable itself. Rule number 3 says if E is parenthesized expression of form, parenthesis, inside parenthesis you have E1, the expression, the postfix notation of the E is same as the postfix notation of E1. So if I have inside parenthesis, say for example this one, this is inside parenthesis 2 plus 5, then the postfix notation of E will be same as that of E1. So example is the same, your E1 is 2 plus 5, the postfix notation of E1 will be 2, 5 and a plus sign. Fourth is the expression is evaluated by scanning from left to right. Always the expression is evaluated from scanning from the left, you go to the right. Say for example is give the postfix notation for expression is 9 into 5 plus 2. Give the postfix notation for this. So first we have to draw the tree. We will draw the tree for simplification. Here you have into is the root, 9 is the left then you have plus 5 and here 2. So in a postfix notation, in postfix, always remember, first we have to write up the left subtree, then we write the right subtree, and then we go to the root. So postfix notation for this will be, first go to the left subtree. Your left subtree is 9, so go right here 9. Then we will backtrack, go to the right subtree. Now this is the right subtree. In the right subtree, again go to the left part. So we have 5. Then go to the right subchild, that is 2. Then go to the root. Root is plus. Then again backtrack and go to the root, that is multiplication. So postfix notation for this will be, this is your answer for the given expression. Let's see one more example. Example number 2 is, give the postfix expression for a plus b divided by c minus d. First drawing the subtree, division will come here. Here you will have plus, here you will have minus, a, b, c, d. So according to the rule, first see the left subtree. So left subtree is this. In this left subtree, see the leftmost element. Leftmost element is a, so first a. Then see the rightmost element. Rightmost element is b. Then backtrack and see the root. Root is plus. Then again backtrack. Then this left subtree is over. Now go to the right subtree. In the right subtree, go to the leftmost element c. Then go to the rightmost element d. Again backtrack, go to the root, minus, again backtrack and go to the root, that is division. So this is my postfix notation. So first drawing the tree and then we see the postfix notation. Always remember, first we go to the left subtree, then go to the right subtree, and then we go to the root. So first, second and third.